I sell, distribute, consult for over 100 different health equipment companies. Best place to contact me is on my website below in the description. Let me know if you have questions or you need a quote or whatever it is. So I'm doing a video right here on a PubMed study. Again, just to illustrate the point, let's say part 2 of why Gforce or acceleration is important to pursue when you're trying to figure out what kind of whole body vibration machine to get for training to get all those different health benefits. Now, let's be real. One of the main reasons that you actually get health benefits from a machine like this, a whole body vibration training machine, is because of how your body has to adapt to the forces it produces. Okay? In other words, your muscles get involved, right? So in other words, it's another form of exercise. Okay. So I constantly educate in a couple other companies and experts about how G-force that is produced on the plate is also very, very important. And in this study, though, they're not necessarily focusing on G-force. What they're focusing on is proving that actually, or what they found out, was that the speed or frequency of a plate is not necessarily, will not necessarily change the amount of workload or fatigue that happens, okay, in the muscles. All right. So why that's important is because there's a few different well-known lineal or linear type vibration machines. Viplate, PowerPlate, and a couple others. DKN, I don't know, I could rattle off some others. But anyways, they'll talk about like, oh, well, it's just the speed. The speed's the only thing that matters, and G-force really isn't important. And okay, but they have their people doing all kinds of different like fancy exercises on the machine. So, and saying like it's definitely gonna give you better results, but they don't necessarily ever prove that. But in this study, they're showing we did a static squatting exercise, 11 different men at 20 hertz, 40 hertz, and 60 hertz. And of course, a control group, right? One session without vibration at all, so just on the floor or the ground. And then they basically had electrodes on a lot of these different muscles here. Okay. All right. And just so you know, those are all leg muscles. Okay. But basically, they're looking for how activated those muscles got. And basically, they did their different sessions, and they essentially found the conclusion is that the voluntary contraction, so in other words, when you try to do resistance, right, when you're actually doing the exercise of squatting, they didn't find any really statistical or significant difference between any of the frequencies in terms of stimulating the neuromuscular system. There was no modifications, no increase in fatigue in those muscles, nothing. It didn't really seem like there was any change between the different frequencies. And versus the control group, which was just not doing it on a plate at all. Okay. So that's an interesting study for sure. And when you do some deeper digging, because it does require deeper digging, because this is a super helpful study, but there's of course a lot more. There's like 2,000 studies. Then what you also find out is like, okay, well, what specific type of machine were they using, right? Because that's also important when you're trying to compare and you look at the studies. So in other words, this study is good because it illustrates that, hey, all right, it's not just about this one setting or specification. It's not just about frequency. A lot of companies want to sell you their machine for whatever price and make it just about the frequency. Like, oh, if you get it and it's 40 hertz, like magic's going to happen. Why are you still working out on the ground, you fool? You should be working out on our machine because it goes to 40 hertz or whatever, right? Like, duh, drop a few $1,000s. All right. So it doesn't work that way. I wish it was that simple. I do. So then what you find is, the machines that were then actually getting results, in other words, producing more fatigue, producing more neuromuscular activation, actually it was correlated to the machine that they were using if it was producing a stronger force behind it. Duh. It makes complete sense if you think about it. Your body has to respond to the acceleration of mass, so the G-force. So think about it. If this, let's just imagine if this plate or this machine that they were using, let's say it was 1 G-force, okay, then then has no results, okay. But imagine if you did these speeds again, but at 3 times your body weight. In other words, the machine was rated at 3 Gs by comparison. So this is just basic physics or logic. Well, if you had these volunteers use the same frequencies while wearing a backpack that had 30 pounds on their back, or that's not even a good analogy. Let's say they had enough weight on their back that was 3 times their body weight.
New visitor.
So that's a lot of weight. Let's just say it's like an extra 250 pounds on the back. Do you think that then they would actually see some activation in their muscles a little bit differently? Of course. It's logical. The G-force does matter. So in other words, if you want to get benefits from these machines, they have to be able to produce enough acceleration force, not just the periodic rate, the cycles per second, not just the frequency. Okay? It's both. They go hand in hand. They're 2 very important specifications. And actually, there's even more studies then that get into, well, it's not just about the force, it's not just about the speed, it's also about how far the plate moves. So the millimeters, or the displacement, how much the plate is moving upwards vertically, moving your body. What's the range that it has to move the body? The easiest way to explain that is like if I pushed you with the full extension of my arm, like I pushed you a foot, right? Like slowly a foot, you'd have to respond to that continual force over a whole foot, over a longer period of time or length, right? But what if I just pushed you maybe just a couple inches, right? And then I was done. Well, your body, of course, has to respond to a force subjected to it, the push, for a much shorter period of time. It's just 2 inches, right? You see the length, the difference there? So that's a great, simple analogy to explain the difference between also amplitude is the measurement, the other important specification. When a plate is subjecting your body to a force for a longer period of time, it's moving your body a longer distance, basically, okay? Or another analogy would be like climbing up a baby step, you know what I mean? Like a really short step up onto a curb, maybe that's an inch high, versus like imagine stepping up onto a chair or like a huge stair that was like a foot high. What do you think's harder? You know, it's obvious. It's the same thing. You're basically having to activate a lot more over that range in order to fully lift yourself up, okay? So your muscle is activated for a longer period of time, okay? So why is that important? Because one of the important pieces of exercise science, like one of the important standards and things that we look for in terms of the quality of an exercise routine, let's just say, okay, and how you make your muscles grow and your neuromuscular system, your nerves adapt and all that kind of stuff, right? The stress has to do with the term time under tension. You can just YouTube or look up exercise and time under tension and read all about it. It has to do with how long your body, your muscles are subjected to a weight or to a force.
New visitor.
And the longer you have to sustain that force or that mass, that increase in mass, the more workload you have to do. So you have a stronger adaptation response to that, okay? So very easy to understand. So all you have to do is say, oh my God, there's like a gajillion studies. We know all sorts of things about time under tension with exercise. How does time under tension play a role with whole body vibration machines? It absolutely does. So that's why most machines don't do a whole lot for you. You literally have to, and if you talk to these companies or sales reps, wherever, and you say, oh, you know about time under tension, right? You know, in terms of exercise, how long you're subjected to a force or mass or whatever. Can you talk about your machine just in terms of like time under tension and how your specifications, you know, help with that aspect of things? In other words, like a truly educated company, and you can send an email in or call in or something. If that sales rep can't tell you, obviously they should easily be able to get somebody, you know, in the company. If their machine is legit, right? They actually have some research and some real R&D behind their machine, okay? So you just ask them the question. Time under tension absolutely is something that you need to learn to analyze machines for and see, is it actually working that principle, that biomechanical principle in the body, thus that I'll actually get benefits from it. So if you are confused about all that, don't worry. I've been studying this stuff for years and years and years. I'd be happy to make some recommendations, consults. Just reach out anytime if you have questions on my website, healthhacksforfeet.com.